What's up? This is Christian. So today I'm going to be solving another medium algorithm problem. So I'm going to be trying to go for a little bit more faster pace, more engaging video. Well, not really engaging, but more fast pace. So what I'm going to do is I'm going to read the problem before I get on camera. Then I'm going to explain what I need to do. I'm going to pause, create a game plan for what I'm going to do, and then explain it as I go. And as we iterate, that'll pretty much be the video. So there's going to be a lot of cuts, I guess pauses in this case. So we'll see how it goes. So this is called Queen's Attack 2. Essentially what's happening is given a position of a queen, it has a certain number of moves it can make, right? So these green dots represent the number of moves it can make. And this is without obstacles. But here, it's going to give us a position of the queen, and then it's going to tell us it's going to have like 3 or 4 different obstacles. And based on those obstacles, it restricts the number of moves it can make. So instead of having 3 extra moves it can make here, it's blocked off because there's something there. We don't know if it's an enemy piece. We don't know if it's a friendly piece. And I guess the interesting part about this problem is that the board is not restricted to being 8 by 8. It can be larger. So this n value is the length of the board's sides, so it can be up to 10 to the 5th, which is crazy. And I guess there's subtasks as well, depending on, I guess, efficiency of your problem. If you can test up to 1,000, then you'll get a 55% of the maximum score. And if you can only test up to 100, then you'll get 30%, which is something I haven't noticed before. So here's an example of the input. So there's going to be, it's a 4 by 4. That's the first number, is the dimensions of the board, and then 0 obstacles. And then this is the position of the queen. So here, see, boom. And then the point of this algorithm is to calculate the number of moves it can make. So here's another example. So it's going to be a 5 by 5 board. It's going to be 3 obstacles. So the position of the queen is 4, 3. It's a little weird. It goes row column. It makes sense to programmers, but I mean, I don't really play chess per se. I know how to play, but I recently it's become pretty popular on Twitch, so I've been watching a lot of Twitch streamers do like speed chess and stuff like that, and I think that's super interesting. It's like really engaging, cool to watch, and it's just like, I don't know, you learn a lot from it. And okay, so these are the obstacles that they put. So it's 5 5, one in the corner, 4 2, boom, and then 2 3. So then the output should be 2 3 4 5 6 7 8 9 10. So the x's, we're gonna assume that we can't reach that point. So this is like for sure. I guess the assumption we should be making is these x's are pieces that are the same color as us. So that means we can't move onto that space. Okay, so I'm gonna pause the video while I create a game plan, and then I'll be back in a second so we can discuss the strategy. All right, so I think I have a decent idea of how I'm gonna do this. It's definitely not gonna be perfect, but we'll try it out. So the idea I have is to run each piece through this series of algorithms. So a queen can go in a diagonal direction. And then it can also go into a horizontal position. I'm sorry. It can also go horizontally or vertically, so how do you spell perpendicular? I'm just gonna put perp. Perp move. Okay. So that's for like horizontal and vertical movement. Alright, so the diagonal move is gonna get the the column. The current column. No. obstacle column and obstacle row. Not obstacle, that's too long. Block. Okay, so we got that. Block column, block row. The reason I'm writing it like that is because when I was doing my little side assignment, I was realizing that in chess they talk about things, the pieces in columns and rows. So the bottom row will be a bunch of letters, so it's like an 8x8 board is A through H, so it'd be like A7. So that's the way I've been thinking of these pieces. I'm by no means a good chess player, but it's just been confusing me. So I'm gonna write it like this just to make it a little bit easier. I'll have to remember that if I need to access an index in an array, that I need to switch those around. So we're checking a diagonal move. Put check, just so we know what we're doing. These will probably be the same over here. So let's copy that. We'll do that. Still really haven't done anything, but here we go. So we'll do a check if. I also need the current row. I don't even know if it'll let me pass it through like that. Block location. Yeah, it'll probably come in through an array, to be honest. Okay. So if the queen location at 0, yeah, this is gonna get confusing. I'm just gonna write these out. Queen column, queen row, block column, block row. So this queen column will be the queen location at 1. And then we'll do the same thing here, except this will be 0. How about this? Go block location 1. Do the same thing here. Okay, so this will keep us organized, well, relatively organized, of course. I don't know if it would have been. Yeah, it's gonna get super redundant, so I think down here I'll separate them. Yeah, because then I'll have to do this in every single method I'm passing this to, which would be ridiculous. So we'll copy this down here so I don't have to write it out again. The queen, it's attack. I could also just write Q. Yeah, that'd be a lot easier. Q column, Q row, X will be the block, just to make things a little bit nicer, you know what I'm saying? Actually, I could just do it like that. I don't know why I did it like that. So I think obstacles is what we're looking at. So we ended up using this anyways. That's hilarious. We're going to be iterating through this, so this will be fine. So this will be always use for throughout, and then we'll go for I in obstacles. No, I hate doing that. It just confuses me, to be honest. It might be because I started off in Java, so we'll go number of obstacles is the length of the obstacles array, or sorry, tuple. So then we'll go for I in num obstacles. We'll iterate through that like this. And we'll go, oops, I'm sorry. We'll go I, and then we'll pass these into whatever we're working on up here. So it'll be like method, and then it'll be Q column. I'm sorry. I'll just copy this up here. That'll be way easier. So yeah, it'll be like just like that, and whatever we end up doing. Okay, so we're gonna go like this. All right. So spent a lot of time setting that up, but that's okay. It'll make our life a little bit easier now that we have that identified or defined. So if the Q column minus X column, not to be the as, I guess let's do it like this. Do it like this. Then we'll do the same thing down here. Yeah. We'll check these. Then we'll do an abs method here. So this is just checking to make sure that it's going in a diagonal fashion, because anytime it moves in a diagonal way, it moves up one row, one column, or back one row, up one column. It's 1 and 1. So we're checking to make sure that it's moving by an equal proportion of that. So it's 1 and 1, 2 and 2, 3 and 3, no matter what. So we're getting the difference, and then we're checking it, the absolute value of that in here, to make sure they're equal for both the columns and the rows. It's one of the genius algorithms I came up when I don't think you guys understand how long I was on that piece of paper. I probably could have gone longer, but I realized I was kind of prolonging the video. So we get that. So then if that's correct, then we can return true, I guess. So I guess we can do a Boolean check. So we'll go how should I do this? Just call it that for now. I'll just copy this, paste that. I think I can already think of something that's going to come up, but I guess we'll do it when we get there. Able perp equals perp. I'm just going to copy this because it's the same. Okay, so we're going to pass that through there. We're going to do that. So the difference in this method is going to be if the column equals X column, or q row equals x row, and that returns true. Okay, so does that make sense? At any given row, it can move to any row that's the same as the original coordinate, and it can move to any column that's of the same coordinate as well. So all these values are true. So now that we have our move logic in place, now we need to test it against the pieces that are coming in. So I guess it's going to be a little bit just a little bit more difficult. So let's see what we can do here. So in my mind right now, there should be an array of at least size 8, right? Because there's 8 different positions it can move to. Let me find a good pick right here. So it's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 possibilities for obstacles in those directions. It's a little bit it's gonna be a little bit confusing. So 8 different obstacles in those directions. So ideally we want to have an index in an array that tests specifically, that is separated specifically for this location. That's the best ideal method. So it is possible to do that, and it would make it more dynamic in a way. I don't know if I used that term appropriately, but hopefully I did. So down here in this main, I guess we can make a closest obstacle. Okay, so this here is getting results. So results could be anything. It could be an array, it could be a tuple. These guys did not. Oh, it is. I think that's a list. I can't remember. Anyways, so we'll initialize this the same way. And then when we're down here checking, that's when we're gonna statically put things in here. Right? Okay. So queen's attack. So we're gonna make another method that checks against check closest obstacle, right? So we're gonna get whatever. Well, since it's static, I don't really know. I don't like using things statically though. It's confusing. Then again, I don't like passing it everywhere too. So we'll go static. Or sorry, it's not static. Global. I've been using the wrong word this whole time. So in here, we're gonna pass a certain index, right? Ideally, so we'll get we'll go current check for now. Goes global obstacle at index right? Does that work? It does not. Okay. So we call this, I'm guessing it's something like this, watch. We initialize the global obstacle, and then we go current obstacle equals the closest obstacle at the index. So I'm guessing we use it, makes the most sense, so we don't have this random global in here. I feel like that does make things a little confusing. So pass that index there, and then we'll compare it to should be the difference, right? We could honestly make this a little bit easier. Let me just get through is that this perfectionist mentality. I keep thinking, hey, I can do this a little bit better, but I haven't even finished like what I'm doing in front of me. I'm over here thinking about changing this, making another method that calculates the difference and the row, and then just using that to pass it into these checks right here. But I mean, I'm gonna have to, I think, to be honest. But I'll do that in a second. So current obstacle is that. So the reason I was thinking about it is because of this. Watch, if difference of the column see if I do it like that and I had the methods already on check, then I'd be able to do this faster. Let me just finish writing this. This is so messy. It's honestly not taking me that long, but it's only 20 minutes in. Okay, so if the difference of the current column difference of the current column is greater than I can't believe I'm writing this all out. This is I've never ever programmed anything like this in my life. I don't know what I'm doing right now. But we're just gonna go with it. Alright, so this is kind of what I'm thinking. So if it's greater or this is greater than what we currently have, then we'll set the closest obstacle at its specific index to whatever we passing here, I guess, since we're checking. Current closest index is versus the current piece, I guess. See, I don't really mind taking a lot of time to do this part, like naming stuff, because when I go back, I'm gonna know exactly what I'm doing. And I've been noticing that it's helping a lot in my programming, because a lot of times I look, I'm like, what does this even do? And I spend like half an hour trying to figure out where this stuff is coming from. But since I've started cleaning up my programming, it's gotten a lot better. Okay, so closest obstacle index is equal to the current piece, right? Yeah, and that's it. Yeah, so this is going to be a 2D array. It's going to be a size 8 by 2 because of the row and column, or column and row, whatever you want to say. All right, cool. Cool. So So we have a pretty decent idea of how we're going to do everything. I guess the problem is I don't know how to calculate the index. I'm going to have to make a separate method that gets the index. Ooh, what if we get this to return the index of what we're working on? That would be great. That would be so good. So then we can just have some sort of way to calculate the index from here. Okay. I can do this. I still haven't done anything with this method. Okay, so I think I'm going to do what I wanted to do, which is calculate these two separately. Because I'm going to be using that a lot for each of these methods, so it's just a simple difference, though. I'll just make things easier. Just do it. I really don't know if this is the move, but this is what I'm doing. Difference of the columns. So we'll go. It's literally the same length though. Whatever. Is this the move? I don't know if this is the move. I think it's like redundant to be doing that. Ooh, okay. Or if I just pass the differences into this. Yeah, and we check the apps here. Okay. We're getting somewhere. Just bear with me for a second, okay? Okay, so what I'm thinking now is in this queen attack, whatever thing we calculated the differences in here and then just pass them over to all the different locations, right? So if I did this, put it in here, like that, we don't necessarily need it for this one. I guess I could, in a way. Yeah, because if they return 0, if either one does 0, then we're in a good place. Okay. So we pass these over to where did I put the loop? Oh, here it is. So we'll do this. Sorry. That's got to be in the loop in order for this to work. Alright, so yeah, X column, X row, perfect. That's exactly what I wanted. And then we calculate this down here using that info as well. And then instead of passing all this, because up here we can use that data to do our checks, right? So we can just do up here, we'll go so we already have those. Check it. So now we're going to do this, and in here we're going to pass a specific index back into this method. Okay, so I don't know what this is for. Calculate the difference. Yeah, I don't really know. Oh, this was for the closest obstacle. Okay, so just delete that. Okay, so we got that. We're passing that in here instead. So let's copy this. Don't worry. we're going to get back to the perpendicular move check. Check this out. Okay, so then up here, we're going to check this against 0, right? Because if either one of these equals 0, I'm sorry, that means it can't be both though, so it has to be, do I write it like that? Oh god, I forgot. It's XOR, that's what I wrote. No, I don't know what's going on. Let me see. This is bitwise though. Maybe it is what I want. Yeah, that works actually. We can do double equals. Yeah, okay. Interesting. Alright, check it. We're getting somewhere. I'm telling you guys. We're getting somewhere. Okay. Okay. So the queen location. Wait, why is it like that? Oh. It's under. Oh, we already got it. RQ. I'm gonna change this. I don't like. Yeah, I like that better. Okay. So we're getting the length of the obstacles. That's actually. Is that what we wanted? Actually, yeah, that is. Well, we could just put n. I just realized I gave us n. Let's do n plus 1. No, we could just do n actually. That's fine. Okay, so now. Hold on, we're gonna pause. I lost my train of thought. Time out. Okay, I started writing a little bit to gain my momentum back. I'm working on the diagonal move method. So instead of testing for when this is equal, we're going to do this as like an initial check. So that way it returns -1, and that -1 is going to mean that the closest obstacle is closer than this piece. So that means that not as many moves are going to be canceled. So we're going to do the difference of the column. We're going to do nx equals. Oh, sorry. Hold up. The difference of the column is greater than 0. Sorry. What does that mean for us? Difference of the column is greater than 0. It's going diagonal up, or diagonal left, or diagonal right, facing upwards, right? Because it's column. No, that's wrong. It's right side. We're going right side. So on the right side, 0, 1, let's see what happens. So we'll make a index value. Start off at 0. Index plus equals 1. How many different checks can I do here? Let's see. And so that means the difference is positive on both sides. So that means down, diagonal, whatever. So it's going to be return. Let's see. We're going to number these. And this is how it's going to make sense. So of square, it's going to be, what is it? A 3 by 3 square. So 0, 1, 2, 3, 4, 5, 6. Okay, so column is going up, so it's to the right, and then the row is going up, which means it's up, so it's going to be 2. So we'll return 2. I feel like this is the least efficient way to do this, but I'm already too committed. Okay, so now we're doing the opposite of 2, so that should be 6, right? Down, down, yeah. So here we're going to return 6. Okay. So we'll do this one greater. So if column is greater, so that should be 4. Interesting. These are all intervals of 2. I feel like I might be able to do something with this more efficient, you know. And then we'll do copy this one, paste it here, and then we'll go this one like this, and then so if the row is positive, that means it's up here somewhere, so it should be 0, right? And 0. Interesting. Look at how this came out. Let me see what happens if we do this one over here. So if this equals this, that means it's not true. So we'll return -1 in that case, and then if not, we'll do our other checks. We'll do the exact same thing here. I wonder, this should be interesting actually. This is going to be a little bit different, honestly. Yeah, so yeah, this is going to be it for this one. So this is going to return difference in the column is greater than 0, meaning it's going to the right. So it's going to be 3. Less than 0, so it's going to be going left. It's going to be 7. This is going to be what is this? Difference of the column is greater than 0. Again? Oh shoot. I forgot to change the row. So we go row here, and then that greater than 0. It's going to be 5, right? No, it's going to be 1 actually. I'm sorry. This is going to be 5. Oh gosh. This is going to be 1, right? Can we do anything with that? I guess not really, because yeah, it wouldn't work. We'll just do it like this. It's fine. So we'll be calling that. That's going to give us the index of each of these, right? So now we're going to pass the max into this check closes. We go max of, and then the index perp. So we're going to pass in that in there as the index, and the current piece is going to be I don't like passing current piece like that. Yeah. So we do it like that. So we're going to get the X column and the X row. Pass that up here, which is going to check this, and it's going to reassign it if needed. So we don't even need to do anything. We don't have to return anything. I don't know if it wants us to. That would be unethical. I'm just kidding. Unethical. That's funny. I guess something I could do instead is, instead of initializing it out here like this, we do it over here in this method. No, we don't need to do that actually. No, that's fine. It's fine the way it is. Okay. So now we have this info. It's critical information. So here we're going to pass the index that we're getting from here into here. No, from here into here, right? Yep, we're going to get the max of these indices. Then we're going to get this, which is perfect. It's not X column. We need the queen's column, right? Ooh, it's passing the current piece. Interesting. That's not what I need, though. I need the queen. Because then I can just pass the differences, right? Kind of long method. Let me just cut this out. Make it a little bit more simple. Okay, so we'll pass the index in here. Call it closest index. Okay, so we're going to pass all that up here. It's going to be really interesting. Pass this here. And then here, we'll calculate the difference of the queen. Yeah, exactly. Let's look at that. I already predicted exactly what I was going to name my variables. So we're going to get that. We're going to go Q column minus minus what? Oh yeah. I don't think I like doing it like this. So yeah, we'll do it like this. And the column will be at index 1. This will be at index 0. Look what the difference by doing that minus that, right? Correct. So now it's a row. It's gonna be this. Look at that. We don't need. Is that right? Yeah, that's right. So changing variables, making it nice and clean. Wish there was a way to make this. I don't like full screen layout. It comes out weird. Ooh, I didn't know I could do that. Okay. Whoa. I think we're going to be doing this from now on. Check this out. This is pretty nice. Okay. Anyways. So we check that versus that. If that is greater or that is greater. So either or, if one is... I'm sorry. It's supposed to be less than. Because that means it's closer, as a matter of fact. Right? Actually, okay, I'm making this way. I guess as of now, I'm making it kind of hard, but it'll all come together. You actually need the current piece passed into here. Interesting. In order to push it into here, I guess I could calculate it, you know. If you go like Q row plus difference of kind of hitting a block here. Yeah, if I do it like that. God, this is so bad. There we go. Column. Oh, we're getting there. -1. Because then it's going to be an index out of bounds since it starts at 1 instead of 0. You see this? These are this is the moves of a genius here. Okay, so we check that. Boom, boom, boom. So then, after all this is done, we just calculate the moves. And then as soon as I did all this, I realized that instead of calculating, instead of saving each individual index, I could have just compared the difference, you know. No big deal. Or the number of move differences. I want to pause it and fix it to that. Might as well. We're already 50 minutes in. Alright, I just spent a little bit of time rewriting everything. This is probably the most confusing thing I've ever done, but here it is. So instead of this global variable for that I was storing each piece's the location of the piece that was in the way, instead I just started storing the distance it actually moved. So that way when I was referring to these indices, I don't have to access and calculate the distance it moves every single time. Instead, I can just compare it to the new distance that I'm calculating. So what I did here, when I calculated the index, as you guys notice, all the indices for the diagonal move were even, and all the indices for the horizontal and vertical moves, were negative. Odd. So I just put a test for that. I did a test for that. So if the closest index was divisible by 2, that means the difference in the row or the difference in the column could be used. So I chose the distance of the column. That's the number of places it's going to move. So then, in other cases when it's odd, then we would use the max value of the difference of the row or the column, because one's going to be 0 and one's going to be some value. So then after that, we're going to find the sum, and that's going to be that, you know. So something I needed to change up here when I'm testing against it, I did still pass the index here and use that to get the difference there. So in the case that it hasn't been initialized yet, um, if it's none or the current distance moved is less than the distance moved, then we would insert it at that index, right? So theoretically this should work, but as you guys know, I always run into problems. Okay, so in obstacles, I is somehow out of range. So let's see. Where's that? Row 5. It's pretty early. No, not row 5. Where is that? 49. Sorry. So 49 is right here. So I somehow gets out of range of obstacles. Not sure how that's possible. Let me think. So n is the size of the board, correct? And by n, obstacles I should be right, theoretically. I to the n. So let's get a little print statement out, see what's going on. So print I out. See what we're getting. Hopefully it's nothing too detrimental. Okay, it's running. So we get up to the very high number of 0. Fantastic. Let's see what's going on. So it's still referring us. Oh, it changed. Oh, because I moved it down. It's referring us to 50. So this here, this I, so obstacles. Okay, I'm going to change back to the other view. If I could figure out how. Here it is. So n is the size of the board, 5 by 5. 3 is the number of obstacles. 2, 3. And then 4, 5. 4, 3, sorry. Is the index of the queen. Okay. So I already see one problem there. I guess I don't really, to be honest. We don't use that too often. This should be fine, right? For I in range n. It's saying, what is obstacles? Where am I getting this? Dot append. So this is blank. Dot append. It's getting the input after it already got the input for it's getting nk, splitting it. So it's n and then the k. That's the first line. Second line is this. That's correct. The third line should be the rest of that. Okay. So obstacles should be, oh, I see what's going on. Okay. Yeah, it's not n by n. You got me. So I had it right initially, but I kind of lost sight of what I was doing. So this should work now. Run code. Alright, we got an answer. Your output is none. Fantastic. It's exactly what we wanted to see. So, what is it checking? So what if I just initialize this to 0? We go 0, 0, 3. How does it make sense? What if we initialize it to we do it like this, and then we initialize it over here using n. what did I call it again? Um, Initialize least distance moved. Pass n into here. In range n, I'll do distance move at n equals -1. Well, no, equals n. How about that? Just do that. Okay, so I mean, to be honest, I didn't even need to. What if it's the way I'm doing it up here? Watch. What if it's the way I'm doing it here? I'm doing it at the index, then inserting it again. Yeah, it doesn't make sense. If we just do append at that location, then it's fine, right? Or we could just set it equal to that, like this. Why don't I just do it like this? This will work. I don't know if that last method I was making stuff on is going to do anything. It's literally nothing. Ooh, we got something. Abs on a tuple. Alright, I'm gonna stop this. Dude. This is kind of a hurt my pride, hurt my ego moment. Over the past couple of weeks, I've been busting out projects. By busting out, I mean, I did two. But, I felt like I feel like I'm getting this massive momentum. I'm finishing these projects, boom, 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 one after the other, one after the other. My knowledge of Python is just getting better and better. But as I do these algorithm problems, I'm hitting these walls where I realize what's going on in my head, and I also feel the pressure of like putting out a good video at the same time. So those two factors combined are great preparation for interviews, but it's definitely a hit at my ego. I mean, I know how to solve this, but I'm so disorganized in my brain that I can't find the solution. I'm sitting here and I'm working on a method and I'm thinking of like two other things I could improve to this. And by the time I get there, everything gets so jumbled up that there's no structure to my program and I'm just lost. And as you guys saw, I mean, the record time is only an hour, but I probably spent total 2 hours on this. Straight up 2 hours. Can you believe that? 2 hours. That's nuts. I can't believe that. And obviously, during a technical interview, they're not going to give you 2 hours to solve anything. Especially a program of this caliber. I have come a long way since I started. Don't get me wrong. But it was this experience was very good, very humbling. It really made me realize that not to get this like cocky attitude, like, oh, I'm great at programming. Because I mean, compared to students I'm taking classes with, I'm doing good. I'm doing really good. But in comparison to where I want to be, I have a long ways to go. But also, in comparison to where I was, I've come a long way. When did we start this? Like 3 months ago? A little bit less than 3 months ago. I've come such a long way. Let's see, August, September. Yeah, 2 months, and I've made this much progress. I'm doing amazing. And I gotta be happy about that. And, I'm kind of when I think I'm good at something, I have this pride. I feel proud. Back in the day when I used to play soccer, I had this mentality like, oh yeah, I don't really try. I'm so good. But the thing is, I had played soccer for years, years and years and years. When we got to high school, the competition improved a lot. And I was still doing the same thing I was always doing. There's guys out there that were grinding day in and day out. And I was sitting here with this mentality, oh, I don't need to practice. I'm better than all these lower level soccer players. And lo and behold, game after game, they kept showing up. They kept getting better and better and better. And I stayed the same. And I felt like I was getting worse. And I was like, what am I doing wrong? And the thing is, I just wasn't practicing. I wasn't even trying. I wasn't even improving at all. 0%. I would just show up to practice, do the bare minimum, go to the games, do the bare minimum. And, it wasn't my choice to quit, but I ended up quitting anyways. And it was probably a good thing because, I mean, it could have destroyed me, honestly. The moment I figured out, either I accepted that I wasn't practicing and I started practicing, or would have destroyed me. I'd have been like, I suck at everything. I'm so bad. I'm the worst. Kind of went on a little ramble there. I'm a little bit upset about this problem. It just shows me that there's so much work to do. It kind of gets me a little excited, a little frustrated, but honestly, when I'm kind of frustrated is when I do my best work. When I'm frustrated, I sit there and I'll grind and I'll grind and I'll grind and I'll grind. If I'm too comfortable, that's when I just don't do anything. I'm just like, whatever. You know, I can get this done later. Hmm. It's kind of an interesting. That's a little epiphany I just had. I'm gonna write that down. Yo, I'm having a moment right now. A moment of, I guess, not enlightenment, but revelation about revelation, revelation. I don't know how to say that word about my personality. I do my best work when I'm frustrated. Because if I'm frustrated, I'm gonna sit there and I'm gonna figure it out. It's gonna keep bothering me. I'm like, I can't believe I can't do this. Like, this is dumb. But if it's like too hard, then I'm just like, you know what, this is too difficult. I shouldn't be able to do this anyways. But if it's too easy, then I'm like, this is too easy. I don't need to be doing it. That frustrated point is like my sweet spot. Just kind of, I need to figure out how to utilize that. All right, so it was nice getting back on. Unfortunately, couldn't solve the problem. I feel like I was on the right track, but I really don't know how to work with tuples, which is the reason I stopped doing this. I'm gonna work on this off camera a little bit later, so I can learn how to do tuples. So the next time something like this comes up, I don't have to stop. I can keep going. But yeah, anyways, nice talking with y'all. Peace.